Friends, we have got a question based on coplanar concurrent forces. So let me read the question. A uniform wheel 40 cm diameter having weight 800 newtons rests against a rectangular block 10 cm thick as shown in the figure. So the figure is given to us here. I'll show you the figure later on. Find the least pull to the center of the wheel to just turn it over the corner of block. Also find the reaction of block. Assume all the surfaces to be smooth. So let me show you the condition what they have shown. So we have got a circular wheel here, friends. You can see here, and this wheel has got 40 cm diameter and 800 newtons weight, and this wheel is resting against this block. So this block has got width. So the width of the block is given as 10 cm. Okay. Now we have to find least pull to the center of the wheel. So through the center of the wheel, we are going to pull this particular wheel to just turn over the corner of the block. So this P is the pull which is acting through the center of the wheel. So we have to find the least pull so that we can turn this particular wheel over the corner of this particular block. Now if you look at the situation, friends, the weight of the block is given as 800 newtons, so that I am calling as W, and the corner point of this particular block I am calling point A. So point A is the corner point of this particular block. So the block is in contact with this particular wheel at this particular corner point at this point A. So there will be a reaction coming at this particular point. So that I am calling as reaction A, RA. So now we got the situation of all the forces acting on this particular wheel. So one force is the reaction acting at point A. The weight is acting downward, that is W, and the pull what we are applying on the wheel is P. Now it is very important to know here that this P is applied at angle 90 degree. So these angles are 90 degree. So this particular force is perpendicular to diameter of the wheel. You can see here this angle will remain 90 degree, friends. So this is 90 degree angle, friends. That is very important. This is 90 and this angle is also going to be 90, as it is very much clear from the diagram itself. So these both angles are 90 degree and this force P is perpendicular to this particular line which is the diameter of the wheel. And this weight is acting vertically downward like this, you can see here, and the reaction is acting along the diameter of the wheel. To understand the rotation of this particular wheel about the point A due to application of the pull force P, let's understand how the wheel is undergoing the rotation. So this is the next position of the wheel, this is the next position you can see. Now if you just concentrate on the position of the weight of the wheel which is acting downward. So this is the position of the weight, you can see here. If you further rotate it, you can see that since weight remains vertical, the distance is reducing. Now weight has become at this particular position. So from here you can understand that the distance of weight which was initially at this particular condition, now here it is at this particular condition. So the distance of weight from point A, which is this distance, you can see. So this distance, let me call D. So this distance is reducing. Initially it was this much. Okay, now this D is reduced. Okay, so as the wheel undergoes rotation, this distance keeps on reducing. As you can see here, the initial position was somewhere here. Now as we are rotating the wheel, the distance of weight is reducing from the point A. So since the distance of weight is reducing, the moment caused by the weight which is trying to prevent the rotation, okay, that is also reducing. So moment of the weight about point A, you can see that moment is also reducing. So the maximum moment due to the weight about point A will be acting when your wheel is at this particular position. Okay, so this is the position where the maximum moment will be caused by the weight about point A. So this is the condition where this particular pull force will experience maximum resistance from the weight. As you will rotate it, you will see that the moment will be reduced and therefore the resistance due to weight for the rotation of wheel will be reduced. It means at this position we have to apply the maximum pull. Okay, this is very important to understand. So this is the position where you are going to apply maximum pull in order to rotate the wheel, and as wheel started rotating, then the pull required to rotate further will be reduced. Okay, so this is the initial position where you will have to apply maximum amount of pull force P in order to rotate this particular wheel or in order to turn it over about point A. So we will have to find out that force where you just wanted to rotate it, just wanted to lift it little bit. Okay, so this is the position, friends, where we have to apply the maximum pull force P. So this is what we have to calculate in order to answer this particular question. Okay, so now this is the initial position, and we are saying that we are slightly lifting it, and at that condition we have to apply maximum force P. Okay, they are asking what? If you read the question, we have to find the least pull through the center of the wheel. So least pull means what? This much force will be least required. Okay, if you apply more than that, it is fine, but less than that will not work, because it will not be able to rotate it, because that time maximum moment will be acting to this particular weight about point A. Okay, so whenever they are asking least force, it means the force which is required to just lift it such that the contact between the wheel and the ground is lost. Okay, if you wanted to turn it over, you have to initially lift it above the surface of the ground. So that much force will be called as the least force required. So what we are doing, we are just lifting it slightly upward. So this is the position we will talk about. You can see in this particular situation, there is no contact between the ground and the wheel. So this is the position which I am talking about. Okay, so now what I will do is, I will draw the free body diagram of this particular wheel, and we will try to analyze the forces acting on the wheel. Okay, so we have drawn the free body diagram, friends, here. Now in this particular diagram, which we are calling as free body diagram or FBD, as we know. So in this particular diagram, we know that the weight of the wheel is acting downward, that is W. The pull we are applying, which is through 90 degree, this is 90 degree, friends. Okay, and then the reaction, which is RA, acting at a point of contact over here between the block and the wheel. So here we have force RA. So I am not going to show RA here, I will show it RA over here, because we can easily transfer the force along the line of action. So I am going to show RA over here, which is the reaction. This is going to be RA, friends. So this force is going to be RA. Mind it, I am just showing this reaction force this way because I need to show all the forces acting in the outward direction or away from the center C, so that I can apply the Lamis theorem. Okay, there are three forces, and all these three forces are acting in the same plane and they are passing through the same point. So it is a condition of coplanar concurrent forces. All coplanar forces, all forces are acting in a single plane, so coplanar, and then they are passing through the same common point, concurrent. So if I want to apply the Lamis theorem in this particular situation, I need all outward forces or all inward forces. Okay, so here I am taking the case of outward forces. So we got pull force P, second we got reaction at point A, which is RA over here, and then we got weight over here. So if you wanted to find the value of RA, which is unknown, and pull force P, which is unknown, the weight is given to us, that is 800 newtons. So we need to find the angles between these three forces. Okay, so obviously this angle is going to be 90 degree, that's not an issue. But now I want to find this angle, friends. So let me call this angle first theta. So if I call this angle as theta, so that angle is going to come over here as theta, as you can see easily. This is also going to be theta. Now if I just extend this line, this horizontal line, friends, you can see here, and let me call this point as point D. So this triangle, what I have shown over here, which is 90 degree here, friends, you can easily understand that this distance from here to here, the whole distance up to here, is going to be radius. So this is going to be radius, friends, the overall distance from here to here. Okay, this is going to be radius. Obviously I have slightly lifted it so that small clearance can be avoided, that's okay. So, and this is width. So in this situation, friend, this is going to be width. The same thing I am going to show here, friends. If I show same thing over here, and this point is point D, friends, so I can easily say this distance from here to here is going to be, overall is going to be radius, and this is going to be width. This is going to be radius R minus the width of the block or height of the block, we can say this is it. So I got, in this triangle I got R minus W, that's okay, and this is again radius R. So I can find out the angle theta by using trigonometric ratios, friends. So let me use the trigonometric ratio. First I will find out this angle theta. You can look at here. So we can say in triangle ACD, angle D is 90 degree, as you can see from the figure itself. So therefore this particular length, so we can say that CD is nothing but radius R. So R minus W, if you do, you will get the value. So R minus W we got here. So CD we got R minus W, friends. So therefore cos theta, which is cos theta, as we know the definition of cos theta, it is adjacent side divided by hypotenuse. So adjacent is nothing but CD and the hypotenuse is nothing but AC. So CD by AC, friends. So we can easily get the value of CD as R minus W and the value of AC is R. So I can easily calculate the value of theta, which is nothing but cos inverse of divided by R. Now in our situation, if you look at, we got the value of R as, because it is 40 centimeter diameter, okay, and the height of this is going to be W, they have given as 10 centimeter. So wheel diameter is 40 centimeter, friends. So radius is going to be 20 centimeter, okay. So R will be 20 centimeter as you can see here, okay, and the width, that is W, is going to be, they have already given 10 centimeter. So R minus W is going to be 20 minus 10 centimeter, so it is going to be 10 centimeter, friends. So theta is going to be nothing but cos inverse of 10 divided by R is 20, as you can see. So it is cos inverse of 1 by 2, and the cos inverse of 1 by 2 is going to be 60 degrees, okay. So it is going to be 60 degree, because cos 60 is 1 by 2, so cos inverse of 1 by 2, 0 0 cancels out here. So cos inverse of 1 by 2 is going to be 60 degree. So this angle we got as 60 degree, okay. So if this angle is 60 degree, friends, so this another angle is going to be, what I'll do, I'll draw this figure separately so that you can easily understand. So in this situation, if you look at here, so this is going to be P, friends, pull. This is going to be RA, okay, and this is going to be weight, as you know. So weight is given as 800 newtons. So this angle they are given as 90 degree, as you can see, okay. So this line, if you just, so this angle we got as 60 degree, friends. So obviously this is going to be 120 degrees, okay, because this whole line is 180 degrees, friends. So this is 120 degrees and this is 90 again, as we know. So we got all three angles required for Lamis theorem, okay. This angle, we got this angle, friends, we got this angle, and we got this whole angle, okay. So these three angles are required if you want to apply the Lamis theorem. So let's apply Lamis theorem here and see what we get out of it. So by Lamis theorem, so as we know that if you take this particular pulling force P, so P divided by sine of the angle between other two forces, sine of 120. So P divided by sine 120 degrees, friends. And then if you take RA, so the opposite angle is going to be 90 plus 60, that is 150. So reaction at point A divided by sine 150, and that is equal to the last, that is weight divided by sine 90. So weight divided by sine 90, friends. So if you solve this particular equation, you can find the value of P. So if you want to find value of P, how to find the value of P, friends? I will take this one and this one together. So we'll get P equals, the weight is 800 and the sine 90 is going to be 1 into sine 120, okay. So if you calculate 800 into sine 120, you'll be getting 692.82, and if you take RA divided by sine 150 and this W divided by sine 90, you'll get RA equals W, that is 800, sine 90 is 1 into sine 150 will be multiplied. This value is going to be 400 newtons. So just by using Lamis theorem and by basic geometries, okay, you can easily find out the value of what? The value of reaction at point A and the pulling force which is required to just rotate this particular wheel, which is having weight of 800 newtons, okay. This is a simple application of Lamis theorem. So we got the answer as RA, that is reaction at point A, as 400 newtons, friends. It is 400 newton, and the second thing is the minimum pull required, that is P, as 692.82 newton. We will see some more examples similar to this to understand the application of Lamis theorem in case of coplanar concurrent forces.